How does America as a country stack up technologically against all foreign and domestic adversaries? How do we prevent unnecessary deaths and attacks to Americans on both foreign and domestic soil? How do we keep you and your family members alive while all at the touch of a button? Through many different strategic means, we rely on direct position and location. Without global positioning system satellites like the 2F satellite systems, we lose the ability to do the before mentioned objectives, to do what we need to do, to be extremely accurate or precise in determining our position. And without this, most military and surveillance operations are dead in the water. In 2014, the Department of Defense alone spent $527 billion. And according to space.com, $8 million of that money went specifically to satellite systems such as the 2F satellite. Using your hard-earned tax dollars, what's protecting you when you lay your head down at night? My entire Air Force career has been dedicated to ground surveillance. I understand the gravity of need for the functionalities of these systems. With satellites like these, my job becomes impossible and the good guys are dead in the water. Today I'll discuss the purpose, function, design, and future of the GPS 2F satellite systems. With a roadmap in place, before I begin to break down the functionality and explain why the GPS 2F satellite systems themselves are so important, let me first tell you why our country is so reliant upon such GPS satellites. Precise positioning is only possible using GPS receivers at reference locations, providing corrections and relative positioning data for remote receivers. They also survey area and are used in geodetic control. Researchers have also used GPS signals to measure atmospheric parameters and complete plate tectonic studies. Well, how do they work exactly? The GPS user segment consists of the GPS receivers and their user community. GPS receivers convert space vehicle signals in position, velocity, and time estimates. 4 satellites are required to compute the 4 dimensions, X, Y, and Z, which are the position, and the 4th, which is time. GPS receivers are used for navigation, positioning, time dissemination, and other research. Navigation in 3 dimensions is the primary function of GPS. Navigation receivers are made for aircraft, ships, ground vehicles, and something we use every day for hand carry by individuals. Now that I've shared with you the role of functionalities of GPS satellites, let me give you a little history of the GPS 2F satellite system. The first satellite in the system, that being the 2F1, was created and then sent into space by means of the Delta IV rocket on May 28, 2010 from Cape Canaveral Air Station in Florida. The last satellite sent to orbit was the GPS 2F8 on April 29, 2015 by means of the Atlas V rocket. These being 2 of the currently 8 2F satellites in orbit. The Air Force launched 2 this year, 1 in March and 1 in April this year, the last forecasted sometime during the year in 2016. So now I've given you a little bit of the history and future of what's to come in the 2F satellite planning. Let me show you a little of what the program has to offer. So what exactly sets apart the system from any other GPS satellite system? The GPS Block 2F satellite, or GPS 2F, is an interim class of GPS satellite, which will be used to keep the Navstar Global Positioning System operational until the GPS Block 3A satellites become operational. According to dailytech.com, these satellites will replace the GPS 2A satellites, which were launched between 1990 and 1997 and designed to last 7.5 years. 11 of those satellites are still in use, including 4 that were launched in 1992. They are being built by Boeing and will be operational by the United States Air Force following their launch of the United States Launch Alliance, using evolved, expandable launch vehicles. They will be the final component of the Block 2 GPS constellation to be launched. The spacecraft have a mass of 3,590 pounds and a design life of 12 years. Like earlier GPS satellites, Block 2F spacecraft operate in semi-synchronous medium Earth orbits with an altitude approximately of 12,710 miles and an orbital period of 12 hours. Because the evolved expandable launch vehicles are more powerful than the old Delta II, which was used to orbit earlier Block 2 GPS satellites, they can place the satellites directly in their operational orbits. As a result, Block 2F satellites do not carry apogee motors in which carry the highest point of orbit. Apart from offering greater navigational accuracy through improvements in atomic clock technology, the satellites also deliver a second civil signal for dual frequency equipment and a new third civil signal to support commercial aviation and safety of life applications. This new satellite is also capable of providing jam-resistant military signals in hostile environments. To conclude, you don't have to be in the dark about technological space advancements that America makes, but rather part of the decision process. Today I discuss the importance of GPS satellites, more specifically the 2F series, that being the way in which it provides precision point reference, the functionality, how position, velocity, and time signals are used to give us geographical reference, and also discuss the history of the 2F satellite series, that being the launch timeline and final capabilities and specs by which the new technology of the atomic clock has allowed us to yield greater accuracy. Now that you understand the technology that we currently use, you can make the choice as a voter what we keep and what we do not. Dr. Martin Luther King once said, "But today our very survival depends on our ability to stay awake, to adjust to new ideas, to remain vigilant, and to face the challenge of change. Our cutting-edge technology advances help keep us a step ahead of the enemy, and without the accuracy in identifying precise locations, we're simply lost."